Hi, and welcome back to the Implementing and Administering Cisco Solutions, the CCNA 200-301 video series course by EC Console. This is Domain 2, Network Access, and my name is Glenn Singh. In this video, you will learn how to configure and verify inter-switch connectivity, or what we call trunking. So let's dive on in. In the previous video, we discussed VLANs and we mostly discussed access ports. Apart from access ports, there are also trunk ports or trunk links. So what exactly is a trunk link? A trunk link are point-to-point connections between a switch to a switch or a switch to a router. So just an FYI, the connection between a switch to a switch or a switch to a router is known as a trunk. Unlike an access port, a trunk allows you to transport multiple VLANs simultaneously. This is why it's very important to create a trunk between a switch to a switch or a switch to a router. Unlike access ports, which allow you to only have one statically assigned VLAN on the interface, a trunk link allows multiple VLANs at the same time. So let's take a look at where exactly we'll place our trunk. So this diagram looks a bit similar to our previous lab. We have a couple of devices, and we can see PC1 belongs to VLAN 10, PC2 to VLAN 20, PC3 30. On this side, we have PC4 belongs to VLAN 10, PC5 to VLAN 20, PC6 to VLAN 30. Now, one of the things that we did is that we created the VLANs on each of these switches. However, if PC1 wants to speak to PC4, it will need to go across this link to to the middle switch. Then from the middle switch, it will go down to this switch across here. The only problem is this. We need to create a trunk link between each of these switches. So between switch 1 and the middle switch, we need to create a trunk link to simply allow VLAN 10, 20 and VLAN 30 traffic to go across. On this side, we also need to create a trunk link to allow VLAN 10, VLAN 20 and VLAN 30 to go across as well. If we do not create a trunk, these VLAN traffic will not be able to pass. So let's imagine that we create our trunk between all of these switches. If PC1 wants to send a message to PC4, the message will enter switch 1 interface here. Once it enters switch 1 interface, switch 1 will tag the traffic with an 802.1q VLAN tagging. In other words, it will insert VLAN 10 as a VLAN ID into the frame itself. So while the switch is passing it on to the trunk, the frame remains tagged until it reaches switch 2. Switch 2 will forward it down here to switch 3, and then before switch 3 sends it out this interface to PC4, it will remove the tag simply because the end device is not concerned about the VLAN tagging. The VLAN tagging is very important within the network devices. The network devices in this situation are the switches. Just to recap, this here is an idea of a frame that has the IEEE 802.1q VLAN tagging inserted. So which means once a frame enters the access port, the switch will insert the VLAN ID 10 as a tag. Now let us take a look at creating the native VLAN and configuring the trunk ports. To create a native VLAN, it is very simple. The native VLAN is only assigned on the trunk ports, not access ports. The native VLAN can be any VLAN number. However, it is not recommended to use VLAN 1. Please keep in mind that VLAN 1002 to 1005 is reserved and is not available to be used. So as you can see here, we create VLAN 99, we give it a name, we call it native. Next, to create a trunk port, you simply go into interface mode. You use the command switchport mode trunk to simply ensure the interface is statically configured to be a trunk. Next, you use the command switchport trunk allowed VLANs and you specify which VLANs are allowed to go through the trunk interface. Please ensure that if it is you are configuring a trunk interface on two switches, let's say switch 1 and switch 2, if you allow VLAN 10 and 15 traffic on this side on switch 1, the same should be allowed on switch 2, 10 and 15. If you do not put a particular VLAN, that VLAN traffic will not be able to go across. For example, on switch 2, we only allow 10, but on switch 1, we are allowing 10 and 15. This means if VLAN 15 traffic is going across, it will be blocked on this side of the switch. So ensure that switch 1 and switch 2 configurations are equally the same. Next, you need to configure the native VLAN. The native VLAN is only assigned to the trunk port. To put simply, we use the command switchport trunk native VLAN and the native VLAN ID. And for added security, we use a switchport no negotiate command, which will prevent the interface from changing between access to trunk. We always want it to remain in the mode we set it here. And switchport no negotiate disables a very important feature, which we'll take a look at later in this video. Here, you can see is the show. This here is the output of a show running config command on a Cisco switch. As you can see, under the interface, these are all the commands assigned. This is one method to actually verify the configurations under a particular interface. However, there's other important commands that you need to use apart from the show running config. So let's take a look at the other important command. To verify trunk interfaces, always use the show interfaces trunk command. This command will tell you which interface is in a trunking state. As you can see, fast Ethernet 0/24 is currently on. It is in a trunking state. The native VLAN assigned to this interface or this trunk is VLAN 99. It is using the IEEE 802.1q encapsulation. Furthermore, we can verify which VLANs are allowed on the trunk interface. So in the event that you think a trunk interface may be misconfigured, always use the show interfaces trunk. If you happen to execute this command and you don't see any results, it simply means you do not have any trunks configured on that particular switch. Additionally, when troubleshooting trunks, always check to ensure the native VLAN is not mismatched in any way. This means if it is you have two switches, and let's say for example the native VLAN on switch 1 is configured to be 99, but the native VLAN on switch 2 is configured to be, let's say, 98, you will get a VLAN or a native VLAN mismatch error. And this error will always present some sort of warning message on the Cisco command line interface. Please ensure that there's no native VLAN mismatch. If a mismatch exists, you will have latency and you will have packet loss on this link. Furthermore, check the allowed list to ensure that the right VLANs are allowed on the trunk interface. To simply check the trunk mode for any mismatches, always use a show interfaces trunk command, which will verify the port, the mode, the native VLAN, and also the allowed VLANs. Furthermore, you can determine the operational and the administrative state of an interface by using the show interface followed by the interface ID with the switchport command. So now that you have an idea of how to configure trunks, let us continue our lab from the previous video. So our objective for this lab is we are going to configure this link to be a trunk and also this link here to be a trunk as well. And on these links, we want to allow VLAN 10, 20, 30, which is our data VLANs, and we need to assign our native VLAN 99 to transport any sort of untagged traffic between switch 1 to switch 2 and also to switch 3. So let's start with switch 1 first for configurations. So to get started, I highly recommend to use a logging synchronous on your VTY lines and your console line. The logging synchronous command will prevent any sort of system message from breaking into any of your commands while you type. The reason why is when we configure the native VLAN on switch 1 on fast Ethernet 0/23 to be 99 and the native VLAN is default as 1 on switch 2, there will be a native VLAN mismatch, and this will show us a bunch of errors which will sort of break into the commands that we are typing in. So to prevent that, we are going to use a logging synchronous command like this. So now that we have set logging synchronous on our console line, let us configure fast Ethernet 0/23 as a trunk interface. Now that we have configured our trunk interface, as you can see, we are now receiving the VLAN mismatch error. What we can determine is the native VLAN mismatch was discovered on fast Ethernet 0/23, which is on our switch 1, and on switch 2, which is this switch up here, it is using the native VLAN 1. So we have 99, but on the other side it is using 1. So hence we'll always get this error message until we resolve the problem on the other side. So now that we have configured switch 1, let us head over to switch 2 and configure both of its interfaces to be trunk. So I just configured the logging synchronous to prevent, of course, the system log message or syslog message from breaking into the command. Now, since fast Ethernet 0/23 and 0/24 will have the same configurations, I can use the range command like so. The range command allows you to configure a group of interfaces with the same configurations. So this means whatever I type now in this interface range mode, it will be affecting both fast Ethernet 0/23 and 0/24 at the same time. So let us configure these two interfaces to be trunks. Okay, so I forgot to turn on the interfaces. So let's do a no shutdown. And now let us verify if we have any trunk interfaces existing on switch 1 that is connecting to switch 2. So since we're on switch 2, we can do the show interfaces trunk. And as you can see, right now on switch 2, we have two trunk interfaces, which is fast Ethernet 0/23 and 0/24. Furthermore, we can see the trunking state, the native VLAN. But we have a problem. We only allow VLAN 10 and 20. We actually forgot VLAN 30. So let us fix this problem. Now let us verify if we have all three VLANs that is allowed through the trunk interfaces. So we use a show interfaces trunk command like this. And now we can see we still have our two interfaces, but now we have VLAN 10, 20, and 30 allowed on both the trunks for fast Ethernet 0/23, which is connecting switch 2 to switch 1. And we have another trunk interface, which is fast Ethernet 0/24, which is connecting switch 2 to switch 3. But we still need to hard code our configurations on switch 3 right now, simply because we still need to fix the VLAN mismatch. And we need to hard set the interface to be a trunk interface and also specify what VLANs are allowed. So let's do this now. So let's head over to switch 3 and make our configurations. Alright, so we made our configurations. Let us verify our trunk interfaces. And here we go. We have fast Ethernet 0/23. It is on. Encapsulation is 82.1Q. The state is trunking. We have VLAN 99 assigned to this interface. We have VLAN 10, 20, and 30 allowed. So all we need to do now is we need to send a ping from PC1 to PC4, from PC2 to PC5, PC3 to PC6, simply to ensure that our VLAN traffic actually going through the trunk. So let's do this now. So let's click on PC1, click on desktop, click on command prompt, and let us get an IP address for PC4, simply because PC4 belongs on the same VLAN as PC1, which is 10.10.10.3. And look, PC1 is able to ping PC4 simply because they exist on the same VLAN. But let's try something unique. Let us ping from VLAN 10, which is PC1, to PC2. PC2 belongs on VLAN 20. So let's try this down here and see what happens. And we should be getting request timeouts. And yes, we are getting request timeouts simply because one VLAN cannot natively speak to another VLAN. To get one VLAN to speak to another VLAN, we will need a router. So that's why we have this router here to do a very special task for us, which is called inter-VLAN routing. So now we verify that VLAN 10 is able to communicate, which is PC1 to PC4. Let us check the other VLANs. Let us check PC2 is able to communicate with PC5, PC3 is able to communicate with PC6. And there you go. Each VLAN is able to communicate with devices that belongs to the same VLAN. Also notice that each VLAN exists on their own subnet. So this is also the importance of learning subnetting. To put simply, it is recommended each department within a company exists in their same VLAN. So for example, the staff, let's say the customer service representative department, let's put them on VLAN 10. How about HR? Probably VLAN 20. What about IT? Could put IT on VLAN 40. What about the servers? Yes, the servers in the server room. Them should also be on a VLAN as well. Let's put them on VLAN 60. Simply by segmenting your network like this and implementing VLANs, you will definitely improve the network performance overall. It is highly recommended each department be placed on a unique VLAN. And don't worry, in the next video, we'll definitely take a look at configuring the router to perform a task called inter-VLAN routing, which will simply allow us for one VLAN, which is let's say VLAN 10, to speak to VLAN 20 and also 30 and vice versa as well. Be sure to save this lab because you will definitely need it for the next video. On Cisco devices, there's a protocol by the name of Dynamic Trunking Protocol. This here simply allows Ethernet trunk interfaces to support different trunking modes. An interface can be set to either trunking or non-trunking, or even to negotiate the trunking status with a neighbor device. The trunking negotiation is managed by the DTP or the Dynamic Trunking Protocol, which simply operates on a point-to-point basis only. The default mode on switch ports are Dynamic Auto, not Access and not Trunk. All Cisco switch interfaces operate on Dynamic Auto by default, and DTP is a Cisco proprietary protocol. These here are the different modes for DTP. By using the switch port mode access command, it simply puts the interface into an access port, as in permanently, so therefore it will never be trunking. Or it will not be negotiating to convert the link to a non-trunk link. So this is why we use the command switchword mode access, so it will always be an access port. There's another command by switchword mode dynamic auto. This simply makes the interface be able to convert the link to a trunk link. This is actually the default mode on all Cisco devices. Well, to be specific, it is the default mode on Cisco switches. Additionally, there's a dynamic desirable mode. This simply makes the interface actively attempt to convert a link to a trunk link. and then there's the switchboard mode trunk, which simply puts the interface into permanent trunking mode and negotiates to convert the neighboring link to a trunk link. And lastly, we use a switchboard no negotiate command. The switchboard no negotiate command simply prevents the interface from generating DTP frames. You use this command only when the interface switchboard mode is access or whether it is in trunk. You must manually configure the neighboring interface as a trunk interface to establish a trunk link. So to put simply, based on the lab that we had done just a few minutes ago, is exactly how we should apply the switchboard no negotiate command. It should only be applied if you use the switchboard mode access command or the switchboard mode trunk command. No other possibilities. Furthermore, on some Cisco switches, you can use a show DTP interface command simply to determine the current DTP mode on a switchboard. However, this command may not work on all Cisco switches. So this table shows you the possibility of having two switches, and depending on the configurations on their interface, what is the outcome. So let's imagine that both of these interfaces here right now is using dynamic auto. So let's put DA. Dynamic auto is the default state. So let's see where dynamic auto intersects. So therefore, the resulting state is an access port. So therefore, between switch 1 and switch 2, if both of these interfaces or these links are running dynamic auto, the result will be an access port. What if one side is dynamic desirable and the other side is dynamic auto? What is the possibility? And where the line intersects, we can see it will be a trunk link. So that's how you actually use this table. A simple way to remember the possibilities is if both sides are access, the end result, it will be an access link. If both switches are in trunk mode, the link will be a trunk mode. If both sides are dynamic auto, it will be an access port. If both sides are dynamic desirable, both sides will be trunk. However, if one side is dynamic auto and the other side is dynamic desirable, the overall result will be a trunk. To put simply, dynamic desirable simply means that it wants to be a trunk. However, it is not recommended to have one side to be access and the other side to be trunk, because you will have a lot of connectivity problems on that link. In this video, you learn how VLANs are able to communicate between switches, you were able to configure trunk interfaces, and most importantly, you learn about dynamic trunking protocol. In the next video, we'll take a look at implementing inter-VLAN routing. I hope this video has been informative for you, and I hope to see you in the next one.